This is our first day of lessons 11.4 through 11.8. We're going to be talking about volume. So three-dimensional figures are what we call solids. So we have our 5 different kinds of solids here. Uh, these two are called polyhedra, kind of like we were able to name polygons versus not polygons. These are polyhedra versus not polyhedra, basically because there's no curves. So we have a prism, a pyramid, a cylinder, a cone, and a sphere. We're going to start with the prism. The prism is 2 parallel and congruent faces that we call the bases, and the remaining faces or flat surfaces are rectangles or parallelograms. We're going to name the prism by the shape of its base, so by whatever exists as 2 of exactly the same shape. So here we would call this a triangular prism because there are exactly 2 triangles and everything else is a rectangle in the picture. This way we call it a pentagonal prism because all we have are 2 pentagons and the remaining sides are all rectangles. This is a rectangular prism because only rectangles exist in it. Rectangular prisms can both be trickier but easier because you could pick any sides to be the bases of your shape, and the formula for the volume of it is a little simpler than we would have to worry about with the others. But because you could pick any 2 sides as the basis, some people get a little tripped up. The volume formula for a prism is V equals big B times H. Big B is the area of the base. And H is the height, but we're going to look at the height as the distance between the bases. Because we will not always have the bases be the top and bottom, which means the height will not always be measured up and down. If my bases were on the sides, let's look back at this one, my bases were on the sides here, connecting them together would be called the height. So let's find the volume of this triangular prism. And I know it's a triangular prism because I see triangles connected by rectangles. So I need to find the area of that triangle to give me the area of the base. And I could already fill in the height of the figure because if I look at the back and the front here, connecting them together is 14, so the height is 14. So let's focus now on this base. The area of a triangle is 1/2 base times height, so that's going to be 1/2 times 11 times 7. And if I do 1/2 times 11 times 7, I get 38.5. So now my volume, if it's big B times H, is 38.5 times 14. So 539. And our units for volume, because we were doing this in 3 dimensions, right? Here's 1 dimension, 2nd dimension, 3rd dimension, is going to be cubic units. So the units are going to be to the 3rd power. So you can go ahead and try this one. Pause. Answers are posted online. Example 2, we have a hexagonal prism. So we're going to have to do our n equals a equals s equals in order to even find b. But I do already know h, connecting the front and back, our 2 hexagons, is 12. So I'm going to put that there right now. So let's worry now about our hexagon. Hexagon, so n is 6, and this 3 represents one of the sides. Let's make our right triangle. If the side is 3, this is 1.5 because it's half of 3. There's our apothem. And our angle is 360 over double 6. 360 over 12 is 30 degrees. So tangent of 30 equals 1.5 over a. Since a is on the bottom, it will be 1.5 divided by tangent of 30, which using our calculator gives us 2.598 or 2.6. So back to big B, which is the area of the polygon, area of the base, 1/2 NAS. It's going to be 1/2 times our list of numbers. And I get 23.4. So my volume, B times H, we get 280.8. And that's meters cubed. Next shape is a pyramid. A pyramid has a polygon base, but the remaining sides are triangles that all meet at a single point called the vertex. So whatever shape is opposite the vertex is your base. We're still going to name our bases by the shape of what's across from the vertex, right? So if I identify my vertex, whatever shape is opposite that would be how we name it. So this would be a triangular pyramid here, a rectangular pyramid here, and a pentagonal pyramid here. The formula for pyramid is similar to that of a prism. It's area of base times height, but now we're going to divide it by 3. So let's find the volume. Our base is a square where sides are 11, so 11 times 11 is 121, and our height is 15. So the volume is area of base times height divided by 3. So you could do this all at once in your calculator if you'd like. We should get a volume of 605 cubic inches. So there's one here for you to try. Pause if you'd like. Answers are posted online. Our next shape is a cylinder, which is basically a circular prism. The bases are circles and they're connected by a single flat curved surface. For our cylinder, the formula is pi r squared h, which is very much like the prism cylinder, the prism formula, because pi r squared is the area of the base, and we're multiplying it by the height. So let's find the volume. If they draw the line all the way across, if they draw the diameter, they're giving you the diameter. So 20.4 is the diameter, which means the radius is 10.2. And my height, the distance between the circles, is 22. So if my volume is going to be pi r squared times height, that's going to be pi times 10.2 squared times 22. So I'm going to do 10.2 squared times 22 times pi. And we should get a total volume of 7,190.73 centimeters cubed. So there's one here for you to try. Pause if you'd like. Answers are posted online. The cone is a circle base meeting at a single point. So it's like a circular pyramid now. And that means our cone formula is very similar to the pyramid formula. We have the area of the base times the height divided by 3. I want us to just pay attention on this picture. There is an L listed here, which is not in the formula. That would have been used for surface area. The L stands for the slant height. If you had the L but didn't know the H, you can use a right triangle and do the Pythagorean theorem to find your missing H. The same thing could have happened in a pyramid, but we're only looking at it right now in the cone. So for example 5, we know that the diameter is 7, so R is really 3.5. And this is the inside height, so it's the real H, it's 4. So let's do pi r squared h over 3, which is going to be pi times 3.5 squared times 4, all divided by 3. So I'm going to do my 3.5 squared times 4 times pi, and I get 153.94, and I'm going to divide that by 3. So I get 51.31 cubic inches for my volume. So you're going to try this one. Please note that 11 is the slant height. You need to find the actual height to do this problem. So if you'd like to pause, give it a shot. Answers are posted online. So our next shape is a sphere, which is the set of all points in space equidistant from a given point. I also have half of a sphere, which is terribly drawn, but we can imagine that. And that would be called a hemisphere. So we should be able to find the volume of both a sphere and a hemisphere. So our sphere volume formula is 4 pi r cubed over 3, so that's r to the third power. Most of our calculators have a button that looks like this or like this that allows us to raise to powers that are not 2. And the volume of a hemisphere is half of that. So if I cut the 4 in half, I now get 2 pi r cubed over 3. So let's find this volume. We have 18 is the radius. I know it's the radius because they didn't draw it all the way across. So we're going to have 4 pi 18 cubed over 3. I'm going to start with my 18 cubed, multiply that by 4 and by pi, and divide my whole answer by 3. So I'm just using my calculator all at once. And I got a very large number, 24,429.02 cubic centimeters. So here's one for you to try. If you'd like to pause, answers are posted online. Here we have a hemisphere with a radius of 2.8. So now my volume will be 2 pi r cubed over 3. So this will be 2 pi times 2.8 cubed divided by 3. So I'll start with my 2.8 cubed times 2 times pi and divide my answer by 3. So I get a volume of 45.98 cubic centimeters. Here's one for you to try. If you'd like to pause, answers are posted online. Now we have the volume of what we call a composite solid. And a composite solid can either be two or more separate solids that we're going to find the volumes of and add together, or two or more separate solids that we're going to find the volumes of and take away. So in this particular one, we're looking at a cinder block, and we're looking at parts of the whole shape not being filled in, which means they are not part of the volume of our shape. So we have one big rectangular prism that we want to find the volume of, and then we have to take away the two smaller rectangular prisms that were basically cut out of the shape here. So I did mention earlier that the formula for volume of a rectangular prism can be simplified to just length times width times height. So for this rectangular prism, the big one, we would do 15 times 8 times 8. So that's 960 cubic inches for the big shape. The two smaller shapes are also rectangular prisms, right? They go all the way down to the bottom, something like this. So the dimensions of this are 5 by 4 by the height, which is also 8. So 5 by 4 by 8 is 160. And there's really times 2 of them because these are the same. So really 320 cubic inches. So the volume of the solid that we're looking for will be our 960 minus our 320. So 640 cubic inches is the volume of our solid. So you can go ahead and try this one. Pause. Answers are posted online. Our next one for the volume is a cube, which is a square prism, and half of a cylinder. So for the cube, length times width times height, we're going to do 4 times 4 times 4. I'm going to even write cube here so I can keep track. Is 64 cubic inches. Half of my cylinder. So that's half of whatever pi r squared height is. The radius is going to be half of this 4 or 2. And the height, the distance between the circles, or the semicircles now, is 4. So if we multiply this all on our calculator, we get 25.13 cubic inches. So this time, instead of taking away, because I'm not cutting out this half of a cylinder from the cube, I'm putting it on top of it, I'm adding it to it, we're going to add these two together. So 89.13 cubic inches is the volume of this solid. So this is the last one for you to try. Answers are posted online, but that is the end of day 1 of volume sections 11.4 through 11.8.